Okay, accelerated math analysis, one of the most important lessons in calculus, the chain rule. Lesson 2.5. You can see our learning target. I can apply the chain rule when needed to find the derivative of a function. But guys, that function will be a composition of functions. One function plugged in inside of another. What could that look like? Well, instead of just having, say, the sine of x, maybe instead of having just an x, you've got the square root of x inside. It's like f of g of x. And, you can see they could say y equals f of u and u equals g of x. That means that what is inside that function, f, is another function itself. That's that notation. And how do we proceed? Honestly, I think right now we want to pay attention to that red box that I just put over there. So what we're getting at is simply this. To take the derivative of f of g of x, we'll take the derivative of the outside function. We'll take the derivative of f, but we still have g plugged inside of it. The derivative of the outside, but then we're going to multiply that to the derivative of the inside. The derivative of that outer function. And you're still going to have the same composition. You're going to have g of x still inside of it. But then you're going to multiply that to the derivative of the inside. So that's really what we've got. This is what we're seeing right here. You can see f is the outside, g is the inside. So take the derivative of the outside, keep the same composition, then take the derivative of the inside. Let's start and take a look at some problems. I hope you can see that there is a composition. What would be the outside function for example 1? The square root of x. And guess what the inside function is going to be? Yeah, you've got this, quadratic, x squared minus 5x. And tell you what, maybe this is one of the nicest ways you can do it. The square root, isn't the square root really an exponent? It's the 1/2 power. And now you can see there's an outside function. Right? There's that outside function. And there's also going to be an inside part. So what are we going to do? To take the derivative, we deal with the outside. If you had something to the 1/2, God bless you, how do you take that derivative? What do? Bring it down. Now you're going to keep the same composition. You'll have x squared minus 5x. But what's your new power here? It's negative 1/2. We have to subtract that 1, right? Yeah. So that's the derivative of the outside. Now I take the derivative of the inside. And that's 2x minus 5. Do you see how that works? Take the derivative of the outside with the same composition. Multiply that to the derivative of the inside. So what's really going to happen? You will probably see this written out when we write our final answer. Obviously, you could join everything together. And x squared minus 5x to a negative power, it means bring it down to the denominator. But a 1/2 power, isn't that really a square root? Yeah. Right? And you could say, well, what about this 2 right here? Well, that's in the denominator also. So this is what our derivative really looks like. Okay? We doing okay with that? So I hope you can see that for number 2, there's an outside. It's right here. There's an inside. So we've got to take our derivative of the outside. What does that look like? Bring down the 8. Keep the same composition. Keep that same inside part that you had. But what's my new power now? It's a 7. Am I done? No, I got to take the derivative of this inside part. What's the derivative of the inside? 5x to the fourth minus 28x to the third plus 2. Now, here, guys, you really can't combine anything else. You're really just done. Okay? You've taken the derivative of the outside multiplied to the derivative of the inside. It might not shock you to hear that one of the biggest mistakes is for kids to forget to take the derivative of the inside. Okay? Okay, so let's look at number 3. Let's look at number 3. Is there an outside function that you can see? That's sine, isn't it? And then there's an inside. So here's your outside. Here's your inside. So let's take our derivative. What's the derivative of the outside function? What's the derivative of sine? It's cosine. Now, the thing is, you still have the same composition. You still have that same inside part. I'm going to write something really weird right now. I'm going to say, this is how you take the derivative of the inside. It's written symbolically. Now, of course, you're probably looking at that at this point saying, wow, that looks so strange. I think we all know the derivative of 4x squared is really what? 8x. Yeah, it's 8x. And kids will say, oh my gosh, Mr. Dobner, do I need to write that down? Truthfully, no. But when chain rules get more complicated, that symbolism might help you. You might say, what are you getting at? I'm talking about the next problem in just a moment, where sometimes your insides get more complicated. That's why you can use this notation that I have right here. If you're ever in doubt, you can say, okay, I just took the derivative of the inside. What do I need to do? Now it's like a brand new problem. I've got to take the derivative of the inside. Deal with that outside part first, then you tackle the inside. Okay? Are we doing okay so far? Okay, now this 2 right here is really shorthand for square that whole trig function. Would you agree with that? In fact, if you had to type that into your calculator, guys, that's how you'd have to type it out. You'd have to write y equals parentheses, sine of 4x to the 2. Maybe now you can see what we're talking about. The inside part has gotten more complicated. But we'll deal with that in just a second. Let's see. Derivative of the outside. What is the outside function? It's something squared. It's like a parabola function, x squared, really. And what is the derivative when you have something raised to the second? You drop down the 2, and then you'd have the sine of 4x. And now this is raised up to the 1. But now you could say, now I got to deal with the sine of 4x. If you're really thinking, guys, you're going to say, that's a composition 2. Do you see what I'm talking about? It's like one of these Russian teacups where you open it up and you'd say, oh, wow, there's another one. You open that up. One of the biggest questions kids have about the chain rule is they'll say, how do I know when I stop? How do I know when I'm done taking derivatives? Well, right now, you got to say, it's like a brand new problem. You'd say, how do I take the derivative of 2 sine of 4x? It's a brand new chain rule, isn't it? It's a brand new chain rule problem. So we got to think about this. Just pay attention right here. What's the derivative of the sine of 4x? You'd say, I got to take the derivative of the outside, right? Multiplied to the derivative of the inside, which is a 4. You see how that gets a little tricky? Well, how do you finish it up? You got a 4, you got a 2. That multiplies to an 8. Then you'd have the sine of 4x right here. Here you've got the cosine of 4x. And then you're done. Okay, we doing okay? All right. You can see how this is going to be like another Russian teacup problem right here. For example, 5. You can see the inner composition will require another chain rule. In other words, like a lot of professors will say is, you're going to have to do a couple of chain rules sometimes, right? So let's think about this real quickly. We could say, well, here's your cosine squared. So I'm going to say this is the cosine of the cube root of 5x. And you know what? Let me even raise this up a little bit because you don't have to recopy it. I just want to make sure that we've got enough space to do this. We'll say that's the cosine of the cube root of 5x to the fourth. And we're going to say that's all squared. But take a look at that cube root. Isn't a cube root really a power? Yeah, it's really 5x to the fourth, and we're going to raise that up to the 1/3 power. Oh my gosh. You can see how this is getting to be a little crazy looking. Do you see what's happening? And this is where that notation can be good. You could say, well, hey, how do I take this derivative? Well, you got to take the derivative of the outside. You'd say, bring that 2 down. Then we'll say, well, then I'm going to have cosine of 5x to the fourth, raise that up to the 1/3, and this is now all to the 1 power. But then what do you got to do? You got to take the derivative of cosine of 5x to the fourth, all up to the 1/3 power. So, if you do it that way, going step by step, maybe that will address the question, how do I know when I'm really done taking derivatives? Let's see what we got. We can recopy this part right here, and now it's raised to the 1. So, I don't have to write that up to the 1 power anymore. I can just write it like this. So now you look right here, you'd say, well, holy smoke, I've got to take the derivative of this thing. It's like a brand new problem. What's the outside function? Well, the outside function, let's be careful. The outside function wasn't to the 1/3. It's really cosine. You see that? It's really cosine. And that's where we've got to be real careful. This whole cube root is inside of cosine, isn't it? And that's why you got to pay so much attention to that. So our outside function is cosine. What's the derivative of cosine? Negative sign. You're going to keep the same inside part here. And then you'd say, well, that means now I take the derivative of this inside. Do you see what I'm getting at? So these are getting tricky. These are getting real tricky. So, here we'd have cosine, and we'll have 5x to the fourth, and we'll raise that up to the 1/3. And here's your negative sign, and you've got your 5x to the fourth, all to the 1/3. And then you'd say, well, how do I take the derivative of this thing? Well, what's your outside function now? The cube root, the 1/3. So I've got 1/3, 5x to the fourth, subtract a 1, I'd get negative 2/3. Now I take the derivative of the inside. What's that? 20x to the third. Holy smoke. Wow, look at that. So what numbers are going to be out in front? A 2, a negative 1, a 1/3, and a 20. 2 times 20 is 40. And you have a negative in front. You get negative 40. Negative 40 over 3, right? And then you could say, well, then I've got cosine. And, if you want to bring that back, you could say here's a cube root of 5x to the fourth. Here would say sine. And you could say, well, here's your cube root of 5x to the fourth. And over here, you could say, well, could I leave that as 5x to the fourth to the negative 2/3? I mean, you definitely could. Oh, by the way, I think I'm forgetting a x cubed here. Maybe you want to bring that x cubed out in front there. This is your derivative. You might see this get dropped down also. So some of these are going to get brutally ugly, to put it mildly, as you're beginning to look at this. Is it possible as you're checking in the back that, or as we give you the answers, an answer might look something more like this, where you'll have bring this guy down, bring your 3 down here. Look at that. This would be probably what we're going to be posting for an answer in the back.